We now need two services to be running for our application, the Quart web server and a Postgres database server to store our data. For this and all of my other courses, I will be focusing on developing with Docker, as this is the preferred development environment used by professional teams. The whole point is repeatability. Everything runs inside containers, so you don't have to install Python, UV, or Postgres on your own machine. If you haven't used Docker before, don't worry. So let's go ahead and set up our Docker development environment. First, you need to download the Docker desktop client for Windows or Mac, which you can find on the Docker website. Once you have the Docker client running, you can check if it's properly installed by typing the following on your terminal. If you see a welcome message, everything is good to go. Let's start by creating our Dockerfile. First, create the directory where the application will live. You can create this directory inside your user's home directory. If you plan to use a directory outside of your personal folder and you are a Mac user, you will need to add it to the Docker client file sharing resources on preferences. So I will call mine counter_app. So I will run make-dir counter_app. Now cd into your application folder and open a code editor to create the Docker file. It looks like this. First, we define the base image as the official Python 3.12 slim image. This gives us a small modern Python 3.12 environment without us having to install Python ourselves. Next, we install UV, our package manager, using pip. We then create the counter_app directory in the Docker instance and set it as the default location for the code. Right after that, we point UV's virtual environment to a location outside our project directory, so it doesn't get overwritten when Docker mounts our local code as a volume. We then copy the pyproject.toml and uv.log files and run UV sync to install all the packages inside the image. Copying the log file first means the install is reproducible, and Docker can cache this layer. Right after that, we copy the contents of the local directory into the counter app directory using the copy command. Once all the code is in place, we open the 5000 port and invoke the UV run command to start Quart. Save the file using the link on screen. Now we need to create a Docker Compose file that will build up both our application instance as well as the Postgres instance. We will create the services using the following Docker Compose file. Modern Docker Compose doesn't need a version key anymore, so we go straight to defining the services, which are essentially the containers that will be running at the same time. The first service is the web application, which we are calling web. We instruct Docker Compose to build the container using the Dockerfile in the same directory using the build statement, and we name the container app_web1. Next, we open up port 5000 both in the host as well as in the container, as this will be the port that Quart is assigned to listen on. Then we mount the current host's Windows or Mac computer directory as a volume inside the container, which will be mounted as counter app. This will allow us to code on the host machine and propagate those changes in the container instantly. We instruct Docker Compose that the web service depends on the DB service to be up. On the default Compose network, services can reach each other by name, so our app will connect to the database simply at the host DB. That's why you'll see DB host, DB below. The next two statements, stdin, open, and tty, are added so that we can execute the Python debugger and examine it from outside the container. The rest of the web service definition is the environment variables. As you can see, they are similar to the ones we'll define on the .quartm file in our next lesson, with some extra ones for the database user and password. Next, we'll define the Postgres database Docker instance. This file is pretty much self-explanatory. We will use the Postgres 16 Alpine image, instruct the container to always restart, put a name for it, and open port 5432 to the host, which is the standard Postgres port. Save the file using the link on screen. We won't start the Docker containers yet, as we need a couple of more things in place.